now that we know how to convert logarithmic and exponential functions, let's put that into use and use it to evaluate logarithmic expressions. Below or to the right, you can see that I put steps on how to evaluate, so we will follow those steps when we do these examples. So the very first step is, so we have log base 6 of 36. We know that y is equal to log base b of x. This is equivalent to b to the y is equal to x. Okay, so the thing is, we have this, like we have the log base 6 of 36, but we don't have it equal to anything. Okay, so our very first step here is that we have to let it equal to something, and we'll just let it equal to y. Okay, unlike when we do word problems, you don't have to tell me what y is. Just put it as a placeholder. All right, step 2, so this is step 1. Okay, step 2, we're going to rewrite this. So when I look at this, we can't do anything about it. All right, so we're not given a calculator, so we got to solve it. All right, so what is this? This is, so if you want, we can still write it. So y is y, your base is 6, and x is 36. Right? If you need to write the values, go right ahead. Okay, it's just whatever helps you. But if you want, you can just go straight to telling me 6 to the y is equal to 36. Okay, if not, just use the values and then plug it in. Okay, to what it's equivalent to. So you just got to know this. All right. So now what is step 3? We want to make the bases the same. So why do we want to make the bases the same? We have y in the exponent, and thinking ahead, what do we know? We know the equivalence of exponential expressions. Okay, so our goal right now is to get the exponents, or to get the bases the same, so we can equate the exponents. Right? So that is step 3. We want to make the bases the same. So what do we know about 36? 36 is the same as 6 squared. Right? Sometimes we will have to change the base over here as well, but right now we don't have to. Like, lucky for us, we don't have to, because 36 is 6 squared. So yeah. So now step 4. Step 4, we're going to use the equivalence of exponential expressions. So what is that? That is, so since the bases are the same, the exponents are equal. And then the 5th and final, or it's not the final step, so should have added it, but it's fine. So step 5, we have to solve for y, but lucky for us, y is already solved. So step 5, done. Okay, so we know y is equal to 2. However, there is a step 6. Okay, so when you say y equals 2, it's like what equals 2, right? Because there is no y in our original equation. So what do? We have to say log base 6 of 36, this is equal to 2. Okay, and this is your final answer. Now, let's do a little bit more practice, and let's do example 2. Right? So example 2, again, we're going to follow the same steps. We have this logarithm. We want to evaluate it, right? So can't really solve logarithms as is, so we're going to use exponential. But in order to do that, I have to let this equal to something in order for us to use its equivalent form. Okay, so let this equal that. Over here, so since there's no number here, what is our base? Our base is 10. When we rewrite this, you can also put 10 if that helps you. Okay, if you don't want to, that's fine as well. Just whatever makes this easiest for you. Right? So now we know this. Okay, so we still can't do anything. So what are we going to do? We're going to put it in equivalent form. So this becomes 10 to the y is equal to 1 over 10. Okay, so so I'll put this in red. So y is equal to y, b is equal to 10, and then x is equal to 1 over 10. Okay, and then remember, let me bring this down. as you can see, this is y, the b is 10, and then x is 1/10. So this becomes 10 to the y is equal to 1/10. Right? Second, let me get more space. Alrighty. So now what do? So our y is in the exponent. Okay. So the only way to get it out is by using the equivalent exponent rule, or equivalent exponential expression. Okay, so how do I get this to be a common base? I see 10, okay, but the 10 is in the numerator, and then the other one, the 10 is in the denominator. So what can I do? Okay, what do we know? We know, so this is 10 to the y. 1 over 10, that is the same as saying 10 to the negative 1. Okay, and so it's like 10 to the negative 1. It brings the 10 downstairs. Right? So these are the same. Now that we have the same bases, what can we do? We can make the exponents equal. Okay, since the bases are the same. And then we usually have to solve for y, but lucky for us, y is already solved. So what does y equal negative 1 tell us? It tells us that log of 1/10 is equal to negative 1. Right? And that's our solution. So we have one more topic to talk about after this, and that is natural logs. Right? So I'll see you guys in a little bit to talk about that.